Hello everyone, so in this video I want to talk about naming polyatomic compounds. Before we begin, I want to make a little quick announcement. So in the last video when I was talking about naming all the polyatomics, I highly forgot, which is one of the most famous ones, ammonium. So that's NH4 plus. And so now let's jump back into our video for today. So for naming polyatomic compounds, I really want you to watch the ionic naming because you're going to take from that, you're going to take from transition metal naming if you have a transition metal, and you need to know your polyatomics. So if you don't know them, watch those, memorize those, and then come back to this video. So let's begin. So for the first one, you have NH4Cl. So remember that ammonium is NH4 plus. Cl is Cl minus. So again, you have a +1 charge on the ammonium and a -1 charge on the chloride and the chlorine. So they're going to cancel out. So that's why you're not seeing any crisscrossing like we talked about in the other videos, because again, they have the same charge. They're canceling out completely. And so that's why you're not having any parentheses or any numbers outside of the parentheses, because again, they're the same charge. NH4 is +1, chlorine is -1. And when I mean same charge, they have like equal charges, I should say. One is a negative charge, obviously, the other one's positive, but I mean they're equal in their charge. So it's like me saying +2 - 2 is going to be 0. Why? Because they're canceling each other out. That's what's happening here. The ammonium is again is +1, the chlorine is going to be -1. So again, they're canceling. So no crisscross. So how do you go into the naming? Well, again, the naming is going to be ammonium chloride. So that's where the little ionic comes in. Remember, you're not going to put chlorinide, you're going to be chloride. You're going to end with the IDE. And ammonium, why? Because that is the polyatomic ion that you have, ammonium chloride. Okay, so I have more examples, so don't freak out if that doesn't make 100% sense. So let's say I have KClO4. So again, I have a potassium, and then I have a ClO4. What is ClO4? And are they canceling? Yes. How do I know they're canceling? There's no parentheses. If there's no parentheses, it's likely going to be canceling. Okay, so if the K is +1, that means the ClO4 has to be -1. So that's why it's canceling. Okay, so what is ClO4 -1 or ClO4 minus? Okay, what is that? So that's going to be perchlorate. So you're going to have potassium perchlorate. Okay, so notice, again, I did this on purpose. Notice that in the first one, you're beginning with your polyatomic, so you're naming it first, and then you're doing your chloride, IDE. But if you're ending with your polyatomic, you're not going to add chloritide or something. I don't know. That just sounds really weird. Again, you're ending with that polyatomic name. So that's it. You don't need to add IDE to the end. You're only adding the IDE. Again, if you have your polyatomic in the first, and then you have chlorine or oxygen or whatever, then you're going to do chloride or oxide or whatever. Okay? Want to show you that. Now, some of you are going to be freaking out and you're like, okay, well, but my professor has a transition metal. What do I do in that case? Okay, I got you. So if you have a transition metal like copper, for example, here, a lot of students, again, they freak out because they're like, wait, how do I even know what the charge of copper in this case? Well, that's why you need to know your polyatomics. If you know that you have nitrate in this example, NO3 minus, so you know copper has to be +1. I'm going to say that one more time and slowly. If you're looking for your transition metal charge, you need to know your polyatomic. In this case, you have no parentheses, so you know that they have equal charge. So if you know that nitrate is NO3 minus, that means copper has to be +1, and that's why it's canceling out. Again, that's why there's no crisscross, because again, they have equal amount of charge. So it's going to be copper 1 nitrate. Again, you need to know your polyatomics to name them. Okay. So what about the next example? You have CuSO4. So you have copper again, but what polyatomic do you have this time? Okay, I'm going to let you kind of put your thinking cap on. So SO4. So if it's going to be what? Sulfate, right? So if SO4 2 minus, then it has to be copper 2, okay? I'm going to show you something. So remember sulfate here as SO4 2 minus. So if you are not seeing again that it has a parentheses, it's because they are balancing each other out. They're canceling out. So again, that has to be a 2 for the copper, a +2 for the copper, a -2 for the sulfate, and again, it's going to be copper 2 sulfate. So what about in this case? Well, in this case, you have what? You are doing the crisscross a little bit. Remember that if you're having barium, okay, if you go to the periodic table, that's going to be in group 2, right? So that 2 was originally in bariums. So it crisscrossed on what? On the hydroxide. The hydroxide gave it its -1 charge. So, I mean, the 1. I'll show you the crisscross in a minute. But again, it's going to be barium hydroxide. And the last one that we're going to talk about is going to be this one. And a lot of students are like, oh my gosh, no, don't freak out. Okay. So remember that chromium, again, is going to be a transition metal. So again, that 3 belongs to the chromium. So you know it's going to be chromium 3. Now, what you need to know is, okay, if there's nothing, no subscript on that chromium, that means it had to be a 1. So it had to be ClO4 minus. And what is that? So it's going to be chromium 3 perchlorate. Okay, so this is what I'm trying to say, because some of you probably are very visual learners and you're like, need to see the crisscross of what I'm talking about. That 3 originally belonged to the chromium. And this imaginary 1 originally belonged to the ClO4 minus. Likewise here, this 2 originally began to that barium. And even though you don't see it, there's a 1 here. That originally began here at the hydroxide. So that's what I'm saying. You already did the crisscross. So I'm just going to do that. But that's what I mean by the crisscross method was already done. Now, again, technically you have a crisscross when you're talking about like potassium perchlorate. But again, since it's the same charge, it really doesn't matter. That's why you don't see it written on the screen, because again, they have the same charge. So for example, here, when I talked about ammonium has a +1 charge and chlorine has a -1 charge, you have a 1 going here and a 1 going here. But since it's the same charge, that's why you're not going to write it down. Okay, I hope this makes it a lot easier. Again, you need to know your polyatomic. You need to know that you're going to end with IDE usually. But if you're ending with that polyatomic, you're just writing the polyatomic. If you're trying to figure out what your transition metal is, you need to know your polyatomic, okay? So again, here, your sulfate, you know is SO4 2-. And so then that's why you knew that copper had to be 2, a +2 to balance it out. Again, here you had a parentheses. So here, since you had that parentheses, you know you need to crisscross back. You know that 3 originally began at the chromium. And you know that if you have nothing here, it's because it's a 1, and that originally began here at the top, which is why it was the ClO4-. So again, use the context clues that they're giving you. It's not hard. I highly recommend that you watch this video multiple times to get the naming down and the other videos. And again, if you like it, if you have any other questions or you need more examples, again, let me know in the comments. And thanks again for watching.